sigma notation was the E-looking Greek letter. So let's do it. So factorial. So you will see in some of these sequences they will have a factorial. Now that it looks like an exclamation point. It pains me to say that.
Because we're so excited for math.
Because you're so excited for math. I like it. So the exclamation point means factorial. It is a mathematical calculation. So if you look at the crazy formula or definition up there, you start at the number and you keep going down by 1. So something simple like 4 factorial, I can do that one in my head. It's just 4 times 3 times 2 times 1. So I'm going to have 12 times 2, got it. 3 factorial, I start with 3, 3 times 2 times 1. Now, before we get into the 0 one, on your calculators, factorial is in your math menu. Notice I just kind of changed the viewing on mine so the screen looks bigger. And if you're going to go over to probability, and you can see it's number 4. So if I wanted to put in 6 factorial, you have to put the number in first. 6, math, probability. So there's 6 times 5 times 4 times 3 times 2 times 1. Now, these numbers grow very, very large. Think about, let's say if I asked you to punch in, well, let's do it, 86 factorial. Punch that in. 86 times 85 times 84, 83, all the way down to 1. 86 factorial. What do you got?
It told me error.
The answer for that is so large, your calculator can't handle it. 86 times 85 times 84, all the way down to 1 is going to be a giant number. So why I'm pointing this out to you, we're going to do some simplifying with these factorial expressions. Clearly, if they're small numbers, yeah, you could just straight type it in your calculator, but you also have to be able to simplify some of these by hand because of the overflow problem. Now, for whatever random reason, it just is what it is, 0 factorial. Well, let's punch it in. If you're like, I don't know what 0 factorial is, you can always punch that guy in. 0, math, probability, number 4. Come on, I hit it twice. 0 factorial is what? You would think it's 0, but it's 1. Avery, did you guess 1?
Yeah, I said it's probably going to be 1.
So that's kind of a unique case. Again, if you can't remember that, punch it in. All right, so back to our sequences. Now, we did this on the A part of our lesson where you're finding the first however many terms. We just threw one of the factorial in it. Remember, you always start with 1 unless, like this guy, there's a note you're starting at 0. So first 5 terms, so we're going to start with a 0. So I'm going to replace both ends with 0. Now, yes, I know you can probably do a lot of the calculations in your head. I'm going to write it out. Anything to the 0 power, 0 factorial. So there's my first term. All right, so now we're going to do 2 to the first, 1 factorial. 2 to the first, nice and easy. What's 1 factorial? 1. All right, let's do the third term here. So 2 to the second, 2 factorial. Well, we all know 2 squared. And 2 factorial is? 2. 2 times 1.
2.
All right, moving over. So let's do the third one. So I'm going to do 2 cubed, 3 factorial. What's 2 cubed? 8. 3 factorial. 3 times 2 times 1. We don't need a calculator. 6. Let's reduce it. Because we always reduce and simplify in here. Oh, 2 to the 4th, 4 factorial. All right, 2 to the 4th, 16. We don't need a calculator. What's 4 times 3 times 2 times 1? 24. And let's reduce it. 8 goes into both. 2/3. All right, we've got the first 5 terms. No more work to go. Got it. Okay. So again, more of the same. Good review of the first section. Just now you have some sequences that have the factorial in it. Now, evaluate the following. So, yes, I am aware. You could just straight type A and B into your calculator, for sure. But you cannot type those variables in there. So, I'm going to do these all by hand so we catch the pattern to use on the variables where I can't use the calculator. Or what if, I'm kind of a jerk bag and I give you one with 86 factorial in it? Yeah. So, I would. Start with the biggest. So I'm going to leave 5 factorial. I always start with the biggest number because I'm going to try to simplify it down to the smaller. Now if I said expand 7 factorial, 7 times 6, okay, so I'm going to start writing that out. 7 times 6, but wait a minute, I'm going to stop here. I'm not going to put 4, 3, 2, 1. I'm going to put that for 4, 3, 2, 1. So I end up with 1 over 42. Ooh. So again, can you type that 1 in your calculator? Yeah, but you know. All right, same deal. Yeah, we've got 3 factorials. Who cares? I'm going to start with the biggest one, so I'm just leaving the denominator. So I'm going to start expanding 8 factorial out. 8 times 7 times 6. So I'm going to stop. 5, 4, 3, 2, 1. I'm going to throw the factorial on for 5, 4, 3, 2, 1 because I see 6 factorial on the bottom. So really I'm at 56 over 2, which is 28. And yes, you could have just straight typed those first two in your calculator, but that's weak. All right, can't straight type these into my calculator. I'm going to have to simplify by hand. Same deal. Start with the larger expression. Easy question, and this is going to come up in that mathematical induction proof section. Which is bigger, n or n minus 1? So I'm starting on the top. So I'm leaving the bottom. So I'm going to expand n factorial. So the next smaller term would be n minus 1, n minus 2, n minus 3. I could go on all day. But for n minus 2, n minus 3, so on and so forth, I see that same expression on the bottom. I'm going to throw the factorial on for all of those. We're down to n. Simple enough. Okay, which expression's bigger, n plus 2 or n? N plus 2, so starting on the top. Okay, so I'm going to expand out n plus 2 factorial, so we're going to have n plus 2. What's your next term? N plus 1. Next term, n minus 1, n minus 2, n minus 3. But wait, we're going to throw the factorial on because I see n factorial in the bottom. I don't care if you leave your answer n plus 2, n plus 1. If you want to get fancy and FOIL them out, I mean, whatever. Or not. That's a quick no. You're welcome to distribute that. Doesn't matter to me how you leave it. I'm just care that you get it down to n plus 2, n plus 1. Okay, next thing I'm going to show you. So we have done, way back, was it Friday? It wasn't track of days when we did the A section, where we talked about the sums, where you had to add the terms together. Maybe I asked you for the sum of the first 6 terms. Well, it wasn't so bad to write out 6 numbers and add them. But if you have to do the sum of a lot of terms, the old graphing calculator will do it for you. I don't know about you, but I really don't have it in me today to want to put 1 in for J, 2 in for J, 3 in for J, up to 10, and then add all those crazy fractions. Your calculator does it for you. So, little screenshots for you. You're going to be in your math menu, and scroll down to 0. You need summation. So here we go. Let me clear this off. Math. Scroll down to 0. You need summation. Sometimes I up arrow and come up from the bottom. I think it's easy. Now, the variable I know is J. I don't care. I'm going to make it easy on myself. I'm just going to switch the variable to X because it doesn't matter. So I'm going to use my X button. 1. I'm going to right arrow takes you to the top. 10. I already forgot our expression. We got 6 over 3J plus 1. Now, I like to use the alpha y equals for the fraction bar, so I don't have to worry about parentheses. So 6, what is it, 3x plus 1, right? 3x plus 1. So this is going to, for you, calculate all the 10 terms and add them in the blink of an eye. There's our total. So if I made you calculate and write out the first 10 terms and then I made you add them all together, that's what it would be. I'm just going to round it. Let's put 5.03 for it. And you can see over here I typed it in without the alpha y equal. You have to use parentheses on the bottom. If it's a fraction, I like the alpha y equal so I don't have to worry about my parentheses or forgetting to use parentheses. Any questions on your calculator? Now don't forget too, on your calculators, if you hit that x comma t comma theta comma n button, n might have popped up for you because remember we put your mode in sequence on Friday. You might need to go back in and put your mode on function. Okay. All right, use sigma notation to write the sum, and then of course we can use our calculators to find the sum. So this is that sigma Greek letter that I really can't draw very well at all. All right, first off, I'm going to pick a variable. I don't know, I'm going to use n. And before I get crazy about what I'm starting at, ending at, etc., I'm going to first try to figure out what the heck is the pattern between these numbers. 3, 9, 27, 81. They're all powers of 3. 3 to the first, 3 to the second, 3 to the third, 3 to the fourth, so on and so forth. So 3 to the n. So there's my expression. And of course we're starting with 1. The question is, count it. This is 3 to the what? Now, choice here. It also wants the sum. So you could hit math 0 and type in what I just wrote in red, or, I don't know, I feel like I could just straight add 6 numbers on my home screen pretty quickly. I don't know, up to you. Add them up however you want to do it. Either hit math 0 or just straight add.
Restart. Yeah.
And honestly, on this one, I don't know which way is quicker.
No.
All right, what do we have for a total?
1,092.
You should get 1,092. Now, I'm already looking at B, and I'm pretty sure I'm probably going to do math 0 on that one, because that looks like a pain in the butt to type all that stuff in. But we'll get to it. We'll get to it. Okay. Let me try to draw the sigma here. All right. I don't care what we use for a variable. I used n last time. I'm going to get fancy and use A for Avery.
Aww.
Here we go.
Or Alex.
No.
Or Alex. Or Alex. Okay. So I'm looking at the pattern here. Yes, this looks like a crazy bunch of mess, but obviously there's some commonalities here. They all have 1 minus. The denominator on these fractions are all 6. So I'm really just kind of copying. I'm like, okay, it's 1 minus. This is over 6. This is squared. So the only thing that's changing in these, of course, is your numerator. So that's going to be our variable, which I picked A for Avery. So first numerator is what? 1 is our lower limit. Upper limit is 6. Now, I personally would not want to have to type, because they don't have in here the 3, the 4, the 5, the middle ones. I would go math 0 on my calculator. I don't want to do that one by hand. So math 0.
Gordy, I'm trying.
Are we under control? All right, so 1 minus, I'm going to put that A over 6 in parentheses, or X I should say, over 6. I'm going to close it up, I'm going to square it. Bam, 125 over 36. Now, depending on how you typed it in, I used the alpha y equals, the horizontal fraction bar, so that's why it automatically kicked me out the fraction answer. If you did it division, like x divided by 6, it might have given you the decimal. It doesn't say what to put, it doesn't matter, so I'm just going to put the 125 over 36. Got it. Circle it all there. All right. On the home stretch. Now, we've been doing sums, obviously, since the very first lesson here. Just clearly here's some more. Just FYI, so, math, we got to have like 5 different ways to tell them to do the same thing. Sometimes they call it a series. Find the series, the finite series. We just did this, okay? So if they call it a series, they're also asking you, hey, I want you to add up the terms. Sometimes they might just say find the series, so you got to know to add. They still might use the sigma, which you know means to add. Difference is finite means you're doing it of a limited terms. We're going to add the first 5 terms. I want the sum of the first 10 terms, whatever. Infinite, just like it says infinite, there's a little infinity symbol on the old top here. Now, you cannot put an infinity symbol in your calculator. So I'm going to show you how we can do that one by hand. Of course, the theme of this chapter patterns.
We're gonna find
Okay, find the third partial sum and then the sum. Okay, well, let's start with the third partial first. So,
Hey, so this.
oh goodness. Now, third partial sum. That just means I want you to do the sum of the first 3 terms. So I'm going to make the upper limit 3. Now, you can hit math 0 and type it in. It's only 3 terms. I'm going to write it out because I'm hoping to use the pattern of it to help me with part B, the overall sum to infinity, which seems weird. Well, all right, let's put 1 in. So 10 to the first, I'm not putting the 1, we just know it's there. What's 10 squared? 100. What is 10 cubed? 1,000. So, okay, 2 ways you could just add those, or if you want to go decimal style, 3/10, 300, 3,000. You add those, 0.333. Now, question. Does that go on forever? Do I use a bar on it? Is it just 0.333? Done?
It probably goes on forever.
Line over the top of it.
Okay, I'm gonna think on that, sit on that. I'm not gonna circle it, I'm not gonna answer that one way or the other yet. Okay, B, the sum. So to infinity and beyond. I couldn't help myself. Now, I already wrote out the first 3 terms over here. I'm not gonna reinvent the wheel. We had 0.3, 0.03. There's the third one. Here's the fourth one. I could keep going, but I'm running out of room.
I'm gonna assume it just keeps
So there is a difference between these 2 final answers. So I'm going to ask again. Does the first one just 0.333, or does that go on forever? Just. This one goes on forever. So I'm going to circle this. All right, and because we love fractions in here, what's the best, most accurate representation of 0.3 repeating? 1/3. Got it. I mean, you could put 0.3 with a bar over it if you're in 6th grade math. I would not mark it wrong. I might just give a frown face
Well,
to
you're
it.
not gonna mark it wrong on it.
Oh, good lord. All right, so you're going to see you can use the sum of the first handful of terms to get to the infinity sum, just for the record today. That is as wild as it gets, my friends.